Welcome to Civil 21D.
Course title, Geotechnical Engineering-1.
Course code, CEN 341. Course teacher, MD Abdulaziz, lecturer, Department of Civil Engineering, Port City International University.
Presentation on permeability of soil.
Namaskar, very good noon to my respective teachers and all of my fellow classmates. I am Nilo Chakraborty, my ID CN02106666. Today our discussing topic is about permeability and our topic is about hydraulic head and its water flow. First of all, what is hydraulic head? It is the measurements of flowing water pressures due to datum specifications. First of all, datum, the lower portions is datum, and here to here the higher portions, it is called elevation head. Then our pressure head and total head. So the total head is equals to Z plus P over gamma W, that means unit weight of water, plus V square, that means velocity square, over 2 times of G. Here we can easily find the pressure head and velocity head. But Z, what is this? First of all, if we make a block of water and here is the datum, then if the its height is Z, then we can tell that the energy is mass into Z into Z, gravitational force. Then we divide both sides by V, then M by V is equals to density, rho into Z into Z. Rho Z means unit weight of the specimen, that means gamma into Z. That then we again divide by rho, that means we can find easily the elevation head. Then when we can go to the surface water of that portion, it can be neglect, it can be count, but in ground surface or groundwater it can be neglected, because in groundwater this velocity is 1 meter per day, that means meter 84400 whole square. It is the value of 12.5 is into 10 inverse 13, that means it is lower than an atom, so it is negligible. And is the for this reason we can told that the flow is running to higher elevation head to lower elevation head, and we can define this all the 3 terms by L. This is the dimensions and its unit is meter, etc. Thank you.
Hello everyone, Assalamualaikum sir. My name is Umayya Tuli and my ID is CEN02106667. Now I discuss this topic. This is happening because of water passing through a soil particle. When water passing through a soil particle, some frictional resistance will be happen. So some head loss will be happen, and that's why energy loss will also be happening. When water flows in the soil, it must flow through many small passages in void sectional of soil. We have to be remind that when water going through a soil particle in void sections of soil particles also. Thank you everyone.
Assalamu alaikum, my respected teacher and my fellow mates. My name is Jawdul Fahim. My ID is CN02106668. Today I am discussing about Darcy's law. What is Darcy's law? Darcy's law is an equation that describes the flow of fluid through porous medium. Here is the main equation is V equals to Ki. Then we find Q Q equals to VA equals to K IA equals to K into dollar H divided by L into A. Then the another one is Q equals to QT equals to KIAT equals to K into dollar H into AT divided by L. Here the denote number is V is discharge velocity, K is coefficient of permeability, I is hydraulic conductivity, I is cross sectional area, Q is flow rate, and the Q is total amount of flow. The true velocity must be faster than average velocity and known as seepage velocity. Thank you everyone, and now I like to invite my next teammate Sadia Arfin to continue this meeting.
Assalamualaikum everyone, my name is Sadia Arfin, my ID is CN670. Now I will continue the presentation. Laboratory determination of coefficient of permeability are two types. One is constant head test and other is falling head test. Constant head test is mainly used for coarse grained soil. The formula of constant head test is K equal to QL by A del H T. If we continuously supply water, the water will flow into this portion, and in this test we will find how much water going on this path, which is denoted as a Q, and how much time will take, which is denoted as a T, and the total length of soil specimen is L. The total cross section of soil specimen is A, and the difference of head inlet to outlet is called del H. That's how we can easily find out the value of K. Thank you everyone. Now I like to call my next teammate Arif Hussain.
Assalamualaikum everyone, my name is Muhammad Arif Hussain. My ID is CN02106672. Laboratory determination test. Previously, Sadia Arfin will discuss the constant head test. Now I will discuss about the falling head test. In this, we use a formula. What is K is equal to small al divided by capital A into T2 minus T1 into ln del H1 and del H2. Then what is del H1? Del H1 is total head loss, and del H2 is this portion. And what is the A? Small a is the cross-sectional area of burette, and capital A is the specimen cross-sectional area. Thank you everyone. Now I like to call next topic. Thank you.
Namaskar, my respected sir. Hello everyone, my name is Tushar Barua and my ID is CN02106675. Today I am going to talk about field determination of K unconfined permeability layer. We already know that what is permeability, and we also know that permeability have two terms. Now we are going to know about the field determination. In this figure we can see that in field determination the impact impervious layer. This impervious, that's mean if we find the impervious below the well, then it will be called unconfined permeable layer. So here we can see that in unconfined permeable layer, first of all we have using pumping, we have to put out the water. We have to put out the water and observe this level. This H2 is when we did not discharge the water, and this H1 is when we discharge the water. And then when it design after before pumping, this water level is R2, distance is from well, this is R2, and we already see that. And after the pumping, this water level is dropped, and this distance will be R1. And then this is our equation for determine the depth, that's mean permeability. And here is Q is the amount of the pumped water per unit time. Thank you everyone. Now my group member Saimul Haq Tanvir will continue.
Assalamu alaikum everyone. My name is Saimul Haq Tanvir. My ID CEN02106676. Now we have to know about confined aquifer. So what is confined aquifer? If a pervious layer is present between two impervious layer, then it will call confined aquifer. It is like a sandwich. For confined aquifer, this pervious layer is called thickness of permeable layer. So it is the total height. So it is the total height. Then it is the total height. It is the total height. Then the rest of the process is like as unconfined aquifer. As my friend Tushar Borua said, the height will be in this the height will be decreases. The decreases height is h1, and the decreases height is h1 from h2, and the influence radius will also decreases. It is R1. Before pumping it is R2, and after pumping it is R1. And if we put the value in this equation, then we can find the value of K. Thank you everyone. Now Zaina Jain Chaudhary will continue.
Assalamualaikum everyone. My name is Juena Zain Chaudhary and my ID is CEN02106681. So now let us know about the factors affecting permeability. At first, particle size. The larger the size of the particle, the more water will enter and the permeability will be high. Structure of soil mass. The larger is the soil mass, the less is the permeability. That is, the permeability of clay is less, but the permeability of sandy particle is high. Shape of particles. Shape of particles. In case of round shape particle, there is more interlocking pore. For this, the permeability is high, but in case of angular shaped particle, the permeability will be lower than the round shape. Void ratio. The more the void ratio, the high is the permeability. Properties of water is also a factor affecting the permeability. Degree of saturation. Degree of saturation. If the soil is fully saturated, the permeability will be low, and if the soil is partially saturated, the permeability will be high. Lastly, absorbed water. Absorbed water, that is the how much water will be absorbed by the soil. That's all for me.
Assalamu alaikum. I'm Mohammad Jasimuddin and ID is CN02106683. Today I'll discuss about imperial relation to calculate K. Here we can see an equation according to Hazans, and the equation K is equals to C into D10 to the whole square. Here K is coefficient of permeability, D is particle size for 10% final, which we get from sieve analysis, and the Hazans permeability is C. The value of Hazans permeability coefficient C is 0.4 to 10. The average value of C is 1. And the second equation according to Chapuis, the equation is K is equals to 2.4622 into D10 square into E cube divided by 1 plus E to the power 0.7825. Here K is the coefficient of permeability, and the D10 we already know. Here particle size for 10% finer, and the E is void ratio, and we have to put all the values in the equation, and then we will get the value of K. And that's all from my side. I would like to invite to my next teammate Farhan Afsar Saqib.
Assalamu alaikum everyone. I am Farhan Afsar Saqib. My ID is CN02106684. We have seen some equations to determine the value of K. Here is another one which is developed by Cosini and Carmen. The equation is K equals to gamma W1 E cube divided by eta W C K minus C S square 1 minus E. Here eta W is the viscosity of water which is fixed, and the value differ with the temperature like 10 degree and 20 degree Celsius. And then Ck minus E is called the Kozeny-Kármán empirical constant, which is generally 5.0 is used. Gamma W is 9.81 kilonewton per cubic meter. Now we have SS, which is the specific surface area per unit volume of particles. We have to determine the value of SS from this formula, and in this formula we have DEFF. So we have to determine the value of DEFF from this equation, and this equation to solve this equation we have to know the value of D average. To determine D average, we have to calculate this equation, and then putting this value here, and again putting this value here, we got the value of SS, and putting this value here we complete the equation. So that was all for today. Next we will continue. Thank you.
Hello everybody, my name is Anindya Das and my ID is CEN689. Here we are seeing the typical values of K. We already determined via different formulas. So this is the typical values of K. For clay particles, the value will be the less than this one, and for silty clay the value will differ between 0.001 and 0.401, and that are all the different kinds of values for the different of soils. So in this slide we are seeing the permeability of stratified soil deposit parallel flow. Here we are seeing that the flow is going this way, and this is the height. So we put the value of H and K here. This is the KH is equal to KH1 into H1 plus KH2 into H2, and it will continue till the n number of H and n number of K. So that will be the values of K. Thank you.
Assalamu alaikum. It is me, MD Kamrul Hassan Riyad from Civil 21, ID CEN021-06690. Stratified soil deposit. Stratified means basically bunch of layers. We can say it bunch of layers in where we can see some layers are placed in here, like 1, 2, 3 layers. As my teammates, as my teammate Anindya Das have told you about the parallel stratified soil deposit, we can see we saw the formula to find the permeability coefficient for parallel soil stratified soil deposit. But what happens if water flows perpendicularly in stratified soil deposit? That's where this formula comes to the picture. We can find the permeability coefficient by this formula very easily. We can see the H1, the height of this layer, H2 height of second layer, H3 which is height of third layer, and we have to find particularly K1, K2 and K number of Kn. It means coefficient of permeability for this layer, first layer, second layer and third layer. Thank you so much. That's for me.
Assalamu alaikum. This is Muhammad Kaimul Haq, IDCN 021-06695. Effect of temperature on permeability. It is a common practice. It is a common practice to reduce coefficient of permeability obtained at different temperature to a standard temperature, which is taken as 20 degrees Celsius. It means the standard temperature of K is 20 degrees Celsius. The coefficient of permeability at temperature T KT can be reduced. It means if we take temperature 30 degrees Celsius, it can be reduced by 20 degrees Celsius, and we can find it respectively 20 degree, 22, 25 and 28 degrees Celsius. The mu-T are mu-20 at viscosity of water at temperature. The mu will be found at the previous slide chart. We can find the mu at the previous slide chart. Thank you everyone. This is for.
Assalamu alaikum everyone. My name is Minazullah Abadan Mahmood, ID CEN 02106696. So this slide is about permeability. What is permeability? Permeability means how much water can pass through a substance. In here it is about soil substance. Okay, so now I'm going to talk about hydraulic head and water flow. Here we can see two water levels. This is the upper water level and this is the lower water level. So the distance between the upper water level and the lower water level is called total head loss. Then here we can see pressure head. It means that the water is experiencing pressure from in this part. So this part is called the pressure head, and then here we can see the datum or the datum line, and the height from datum line to the middle part of the water layer is called elevation head. So total head stands for HZ, which is known as the datum line, and then HP, which is known as pressure head, and HV, which is the velocity head. So altogether HZ stands for Z, then HP or the pressure head, it stands for P by gamma W, and velocity head it stands for V square by 2G. Now I would like to invite Shamim Kaisarana for further discussion.
Welcome everyone, I am Shamim Kaisarana. My ID is CN02106699. Today I would like to discuss about hydraulic head and water flow. That is happening because water passing the soil particle, and when water passes the soil particle, then some frictional resistance will happen. So head loss is an energy loss. Then we have reminded when water flow in soil, it must flow through the many small passages in void sections of soils. Thank you.
Assalamu alaikum everyone, I am Bibi Fatima, ID CN 02106700. Darcy's law. Darcy's law states that the rate of fluid flow through porous medium is proportional to the potential energy gradient within that fluid. V is equal to Ki, Q equal to V, A equal to Kia. In here V is equal to Ki equal to K del H by L into A. Capital Q equal to Qt equal to KIAT equal to K del H AT by L. True velocity must here V equal to discharge K means coefficient of permeability, I means hydraulic conductivity, A means cross sectional area, small q means flow rate, capital Q means total amount of flow. True velocity must be faster than average velocity and known as seepage velocity. Vs equal to V by N. That's it. Thank you all.
Assalamu alaikum everyone. I am Mohammad Tasin. My ID is CN702. Now I will discuss about the laboratory determination of coefficient of permeability test. There are three types of tests. I will discuss one types of test. Constant head test. Constant head test is mainly used for the coarse grain soil. In this test we in this test, in this test we continuously supply the water diffusion. Then we diffusion, the water is supplied for the water is flow by the diffusion. Here this is a specimen. L is the specimen length, and L is the specimen length. Now we calculate the K, coefficient of permeability. Then we need some value Q, L, A, del H and T. Q is the coefficient of Q is the discharge rate, L is the specimen length, and A is the area of cross section area, del H the head difference of diffusion to diffusion. T is the how much time this water are flow in this fusion. Thank you everyone.
Assalamu alaikum everyone, I am Habibur Rahman, my ID is CN021067009. I will discuss about determination of coefficient of permeability. This is denoted by K, and this test is falling head test. Falling head test, we needed a burette. This is a burette, and this portion passing the water, and this is specimen, and pass this part. Falling head test, this equation is K equal to small a divided by capital A into T2 minus T1 ln del H1 divided by del H2. This height is del H1 when time T equal to 1. T1 is initial time, and small a is the cross section of area is burette, and capital A cross section of area is specimen, or L is the length of specimen. Thank you everyone.
Assalamualaikum sir, good afternoon everyone. I am Oishi Borua Diba. My ID is CEN02106717. I am from group 5. As we already came to know about the laboratory test for the coefficient of permeability, which is denoted as K. Now I am going to talk about the field identification test for the coefficient of permeability. Usually for the field identification test, the pumping out test is conducted. In this test I will discuss about the unconfined permeable layer. In an unconfined permeable layer there is an impervious layer below the pervious layer. Here what is pervious layer? Pervious layers means through which water can easily pass, and the impervious layer means which does not allow water to soak in the ground. We can say that impervious layers does not allow water to pass through it. In this test, first a well is excavated through the permeable layer, and two observation wells are installed at R1 and R2 distances. Here the original water table is this, and the water will be pumped out until the height of the water at the well, and the two observations will be stable. Here after pumping the water table, the water influence radius will be like this. Here the height is H2, and after pumping water the height reduced to H1. So now we have four terms: H1, H2, R1 and R2, and another term is Q, which is the amount of pumping water per unit time. So we can now easily determine the coefficient of permeability through the equation K equal to Q by pi into H2 square minus H1 square into ln R2 by R1. Thank you everyone. Now Shatabdi Mitra will tell you more about the field identification test.
Namaskar sir, hello everyone. Now I am going to present confined aquifer. Here we can find permeous layer and two impervious layer and one pervious layer. First we need to know what is confined aquifer. impervious layer is present there and pervious layer is present between the two impervious layer, so the term is called confined aquifer. Confined aquifer is look like a sandwich. Why it is called sandwich? Because we see the picture, we see that two impervious layer is present there and permeous layer is occupied in the center position. That's why it is called sandwich, look like sandwich. Here a center oil is dragged into the lower impervious layer. This oil is called center oil. This oil is called center oil. Here after and two observation oil also dark, and after the height of the H2 is the height before pumping, and H1 is the height after pumping. After pumping, the radius R1 also decrease, and also decrease. The formula of the confined aquifer is K equal to Q by 2 pi H to H2 minus H1 ln R2 divided by R1. In confined layer, H1 is the thickness of permeable layer. After before pumping, the R1 is R2 is decreased, and after pumping R1 also increase gradually. H2 and H1 and H2 will be decreased. Now my teammate Songrama will continue the next part of this presentation.
Okay, good evening everyone. My name is Songrama Chajje. My ID is CN021067020. Now I am discussing about the factor affecting permeability. The first term is the particle size. If the particle size is large, then the permeability will be high. Structure of soil mass. For the clay particle, the permeability will be low, and the sand particle, the permeability will be high. The shape of particle, we know that for soil there are many shapes that are like rounded shape and angular shape. For the rounded shape, the permeability will be high, and the angular shape, the permeability is low. And the void ratio. The void ratio for which soil void ratio is large, then the permeability will be high. The properties of another term is the properties of water and degree of saturation. If the particle is fully saturated, then the permeability will be low, and if the degree of saturation is low for the soil particle, then the permeability will be high. And the last portion is the absorbed water, and it is the important term of affecting permeability. Please turn the next slide. Okay, now I am discussing the empirical relation of the calculated K. What is K? K is coefficient of permeability. The first equation for the sandy soil, according to the Hazen, K equal to C into D10 whole square. Here C is the Hazen's empirical coefficient, which range from 0.4 to 10, with average value is 1. And D10, we already know that what is D10, the particle size for which 10% of the soil is finer, and we find it from the sieve analysis graphs. The next equation for sandy soil, according to the Chapquis, the K equal to 0.4622 into D10 whole square, D10 square into E cube divided by 1 minus E whole 0.7825. Here E equal to void ratio, and we already know this what is void ratio. Void ratio is the volume of void divided by volume of solid. Thank you everyone.
Assalamu alaikum everyone, I am Muhammad Arifur Rahman, ID CN021067112. We already see the in the previous slide for find out the value of K. Here is another important formula which is developed by Kujani and Charmans. K equal to gamma W by mu W into 1 by C K minus C SSS square into E cube by 1 minus E. Here mu W equal to viscosity of water. This is also fixed 1.307 into 10 inverse cube Newton second per square meter for T equal to 10 degrees Celsius. And T equal to 20 degrees Celsius, we used 1.002 into 10 inverse 3 Newton second per square meter. Here Ck minus C equal to Kujani-Charman's imperial constant, which is also fixed, and generally it is used 5.0. Here gamma W equal to a specific weight of water 9.81 kilonewton per cum, and SS equal to a specific surface area per unit volume of particle. Here if SS, the value of SS is given in the question, we directly put it down here for find out of K. If it is if the value of SS is not given in the question, if we find out of S, we develop this formula for find out of S. After find out of S, the value we put it down here, and E equal to void ratio equal to volume of void by volume of solid. And thank you everyone.
Hi, I am Hassan Islam. My ID is CN02106718. Now I will discuss about SS. SS means specific surface area per unit volume of particle. Here SS is equal to SF del D df. Here SF is shape factor. Now we find DEFF is this portion. Here 100% by sigma into F1 by D average. Here F1 means function of particles between two sheaf size with D1i as large as DSI as smaller sheaf. Here D1 larger sheaf and DS smaller sheaf. Now we find D average this portion, and now the value we put this equation, and the value of DEF we put this equation, and then the SF we put this equation, and we get K. That's all everyone.
Assalamu alaikum everyone. My name is Mohammad Shariful Hassan Fahim. My ID is CN02106726. Here we can see the typical values of K. What is K? We already determined so many formula to use the K. Finally, the summarize that for clay the values of K will be less than this one. For city clay, the value it will vary from this portion. For fine sand, it will be vary from this portion. For coarse sand, it will be vary from this portion. And clean gravel, it will be varies from 100 to 1. So you have to keep your mind to use this for use these values in different mathematical problems. Thank you. Now I'd like to request my next statement.
Assalamu alaikum everyone. I am Mahfuzul Islam Shufar, ID CN02106731. Now I'd like to discuss about permeability of stratified soil deposit parallel flow. We all know that soil can be arranged parallel, vertically or horizontally in different layers. Here the flow will have parallel or perpendicularly. Then if we want to identify the coefficient of permeability in parallel flow, then we have to use this equation. Here in every layer we have the discharge velocity, hydraulic conductivity, by which we can find equal to Ki, and by this we can find coefficient of permeability for every layer, and then we multiply it with the height of parallel flow layer. Then we can find the total coefficient of permeability for parallel flow. Thank you everyone.
Assalamu alaikum everyone. I am Ramiz Ahmed Chaudhary. My ID is CN02106728. Today we are going to know about permeability of stratified soil deposit perpendicular flow. If the water flows downward or vertically, it will be called perpendicular flow. For perpendicular flow, we will use this equation. At first, we have to determine total H. That is this one. This layer is H1, this layer is H2, this layer is H3. We have to put it down with the values of K. We will take sample from this layer, another sample from this layer, and also from this layer. By doing lab test, then we will find K1, K2, K3. After putting combined K values, we will find total K, that is coefficient of permeability. Thank you everyone.
Assalamu alaikum everyone. I am MD Nokibul Islam Saif. My ID is CN02106733. Today I will discuss about the effect of temperature on permeability. Our previous group already described how to determine coefficient of permeability, but they didn't take the value at standard temperatures. Now I will teach how to convert it at standard temperatures. The value that taken at 20 degrees centigrade is known as the standard value for coefficient of permeability. Here you can see a formula, that is K20 is equal to mu T into Kt upon mu 20. If we familiar with this 4 types of value, then we can easily convert it at 20 degrees centigrade. 220 degrees centigrade of coefficient of permeability. Here mu naught is equal to viscosity at any temperatures. Mu 20, that means viscosity at 20 degrees centigrade. Kt, that means coefficient of permeability at any temperature. If we know these 3 unknown value, we can easily convert it at to 20 degrees centigrade. That's all for today. Thank you everyone.
Assalamu alaikum everyone. I am Minhar Abdullah Galib. My ID is CN02106734. Today we will find out coefficient of permeability. Hertz is void ratio is equal to 0.6. D10 is particle passing 10% finer. We will find out from sieve analysis. K is equal to coefficient of permeability. According to Chapuis, we know K is equal to we know 1 centimeter is equal to 10 millimeter. So the answer is that's all. Thank you.
Assalamu alaikum. My name is Nawaz Sharif. ID CN02106738. Hydraulic head and water flow. we see a picture, hydraulic dam and hydraulic head. Hydraulic head is equivalent to the water level in a static water body. Another graph chart is soil particles here and frictional resistance. What is soil particles? Soil particles, the particles that make up soil are categorized into three groups by size: sand, silt, and clay. Friction resistance. Friction is a force and the resistance of motion when the object rubs against another. Thank you, everyone.
Assalamu alaikum, this is Sharif Manwar Islam, my ID is CN02106741. Today I am going to discuss about Discharge law, discharge velocity and seepage velocity also. Discharge law states that the rate of fluid flow through porous medium is proportional to the potential energy gradient within that flow. Then discharge velocity is the volume of water flowing in unit time across the unit across section proportional to the direction of flow. Here we can see equations of discharge velocity. Here V is equal to Ki. K is coefficient of permeability and I is equal to hydraulic conductivity. And then last topic, and seepage velocity. Seepage velocity is the velocity of groundwater calculated from Discharge law. Seepage velocity is also proportional to the hydraulic gradient. Here you can see equations of seepage velocity. Vs is equal to V divided by N, where V is equal to total volume of soil and N is equal to porosity of soil. That's all. I like to.
Hello everyone. Assalamu alaikum. My name is Asim Jilan Shanur, CN02106737. Now I am talking about laboratory determination of coefficient permeability constant head test. We can see a constant head test machine. Now I am talking about the constant head permeability test is a common laboratory testing method used to determine the permeability of granular soils like sands and gravels containing little or no slate. This test method is for testing constitute or disturb granular soils samples. Thank you.
Assalamu alaikum everyone. My name is Fasulunuk Tuhin. My ID is CN742. I will discuss about falling head test. What is falling head test? The falling head test is one of the variable head test procedure that is undertaken in situ in a borehole to determine the permeability of a soil. The falling head test is used to both for coarse grain soil as well as the fine grain soil. It has the same procedure in constant head test except record initial head difference H1 at t equals 0. Record the final head difference H2 at time t equal T2, collect water at the time outlet Q ml at time t equal 60 seconds. We know that coefficient of permeability is K and we can calculate the K as AL divided by AT ln H1 divided by H2. Here A is the inside area of stand pipe and capital A is a cross-sectional area of a specimen. That's all. Thank you everyone.
Assalamu alaikum. I am Istaq Haidar, ID is CN02106746. Previously we will known about the title of factor affecting permeability. Now we will discuss about detail in factors affecting permeability. So one particle size, the permeability varies approximately as the square of diameter of soil K is equal to 100 D10 square, where D10 is the effective diameter of soil. Two properties of pore water. The permeability of the soil varies directly with density and inversely proportional to the viscosity of the water. In here we see a picture which is properties of pore water diagram. 3 void ratio. Increase in void ratio increases the area available for flow, hence permeability increases.
which is K is proportional E cube divided by 1 plus E, where E is the void ratio, and we see a graph of void ratio. For a specific surface area of particle, a specific surface area of soil particles also affects the permeability. Higher the specific surface area, lower will be the permeability. K is proportional 1 by a specific surface area. That's it for today. Assalamu alaikum.
Hello everyone. Assalamu alaikum sir. Assalamu alaikum everyone. I'm Naimul Islam Nabil, height is 0.06751. Today I will discuss about permeability. Okay, let's start. First of all, shape of particle. There are two shape of particle. First one is round shape of particle, and another one is angular shape of particle. Round shape of particle is more permeability than angular shape of particle. Okay. Next topic, soil structure. There are two types of soil structure. First one is flocculated structure, and another one is dispersed structure. Flocculated structure, if soil particle oriented randomly, is called flocculated structure, and if soil particle orientation face to face is called dispersed particle. Flocculated particle is more permeability than dispersed particle because of their particle orientation. Thank you everyone. I would call to
Assalamu alaikum. Okay. Assalamu alaikum sir. My name is Dr. Mobum and my ID is CEN0210670. Now my first of all I tell about degree of saturation. Partially saturation soil contain air, but this air will block the flow part, thereby reduce the permeability. Fully saturated soil is more permeable than partially saturated soil, and this picture we see that partially saturated and that's fully saturated. Then I tell about observed water. Observed water is the water layer formed around the soil particle, especially in this case of fine grained soil. This reduces the size of the void space by about 10%, hence permeability reduce. Now interpret air and organic matter. Persons of interpret air and organic matter observe flow, those displace the permeability. And in this picture we have this the void and the air or water pore. Thank you.
Hello everyone, assalamu alaikum. I am Fazlur Bishanta and my ID is CN753. So now I am going to discuss about two types of velocity that we can see in terms of soil. First one is superficial velocity. Superficial velocity is defined as the discharge per unit cross section of the soil. That means here we consider the total area of the soil, that means the area of void plus the area of soil solids. In this figure we can see the water is flowing in this direction. So in symbols we can write V is equals to Q divided by A, where V is our superficial velocity, Q is the discharge per unit time, and A is the area of the soil sample, that means the total area. Then seepage velocity. Seepage velocity is defined as the discharge per unit cross section area of voids in the direction of flow of the soil. In this picture we can see the water is flowing in this direction and the water particles flowing through the voids. That means in symbols we can write Vs is equals to Q by As, where Vs is our seepage velocity, Q is the discharge per unit time, and As is the area of the voids. In our previous superficial velocity we calculated we measured the total area, that means area of solid and area of total voids. So seepage velocity is called the main velocity of the soil, and hence seepage velocity will be greater than superficial velocity. Thank you everyone. Now I would like to call my next teammate.
Assalamu alaikum everyone. I am Rabia Khatun Mim, ID 021067660. Now I am talking about empirical relation for K. We already know about empirical relation for uniform sand according to Hazen. Now I am talking about for compacted sand according to Hazen. K is equal to 0.35 D15 square, where D15 is the particle size for 50% finer soil. from this graph we will know about D15. For medium to fine sand, this is also from Hazen. K is equal to 1.4 E squared K 0.85, where K is the hydraulic conductivity at a void ratio E. K 0.85 is the corresponding value at the void ratio of 0.85. For sandy soil, according to Carrier, K is proportional to E cube by A plus E, where E is the void ratio. Thank you so much.